Alrighty, this will be the longest video because there is the most information. We do have 4 different types of transformations to cover, so let's go ahead and get started. So the main transformations we have are translations, which is just sliding objects in the coordinate plane. It preserves congruence and orientation, meaning they're going to be the same size, they're facing the same way. Rotations are turning objects in the coordinate plane. It's going to preserve congruence and orientation. Reflections are flipping objects in the coordinate plane. It preserves congruence, meaning they're the same size and same shape, but it does not preserve orientation. Dilations are enlarging or reducing objects in the coordinate plane, and it's always by multiplying by a scale factor. So as soon as you hear the word dilation, you should be thinking multiply. This does not preserve congruence because I'm changing the size, and essentially congruence means same size, same shape. So if I change the size, it's no longer congruent. They are similar shapes, however. Let's talk about translations. If I have a horizontal translation, that means I'm moving in the X. And when you move in the X, if you vertical is moving in the Y. But when we're moving in the X, left is negative, right is going to be positive. Think about the way the number line works. The negative numbers are on the left and the positive numbers are on the right. Vertical, like I said, we're moving in the Y. When we move in the Y, okay, if I move down vertically, that's going to be negative. And if I move up, that's going to be positive. So those are the directions you're moving for translations. So it says translate point P 5 units horizontally and -3 units vertically. Okay, so there's point P. I'm going to move it. It's currently at -3, 3. And I'm moving it 5 units horizontally, means we're going to move 5 spaces to the right because that's a +5. And when we think about horizontal, we're thinking about X, and X is positive to the right. So I move 5 spaces right. -3 vertically means we're going to go down 3 spaces because when you think negative in the Y, you're thinking down. So I go down 3. So point P prime is located at 2, 0. Remember that prime is your new shape, or it's the image. The pre-image is the original shape. Now we have translate triangle PQR, -4 units horizontally and 1 unit vertically. Okay, well there's PQR. It's currently at P is 4, 0, Q is 6, -6, and R is 2, -4. So I'm going to go -4 units horizontally. Okay, horizontally is in the X. Negative in the X means we're moving left. So I moved left 4 units. And then 1 unit vertically. Well, that's a positive. When we're talking about positives in the Y, we move up 1. So finally, we have P prime is at 0, 1. Q prime is at 2, -5. R prime is at -2, -3. Rotations is all about turning objects in the coordinate plane. We're going to rotate objects either to the right, which is clockwise, or to the left, which is counterclockwise. You can do a 90-degree turn, which is only 1 turn. 180 degrees is 2 turns, or 270 degrees is 3 turns. Now, I'm going to focus a lot on actually turning the coordinate grid. And remember, when you're doing this, you'd be turning your Chromebooks. The reason I'm focusing on that is because it's a lot to memorize the rules for rotations. You can do it, but the process is easier if you can actually remember how to turn it. So here's an image just showing how we rotated this pre-image to create all the images. So here we go. We're going to rotate point K 180 degrees counterclockwise. Okay, counterclockwise is moving left about the origin. So 180 degrees is 2 turns, and I'd be moving it left 2 turns. So eventually I'm going to end up here in quadrant 3. That's what this point is going because I did 1, 2 turns to the left. So let's practice this. Remember, we're focusing on moving the actual Chromebook. So you would be turning this. So I'm going to turn it 1 turn to the left, and turn it another turn to the left. See how my graph is now all turned around? But that's because we're physically turning our paper or our Chromebooks. Now I can relabel our top right quadrant, quadrant 1, top left, quadrant 2, bottom left, quadrant 3, bottom right, quadrant 4. And we know that quadrant 1, all our numbers are positive. So we're just going to pretend like we're using this as the real quadrant 1, even though we know quadrant 1's over here now that we've turned it. So from the origin, I go left 6 units. When you go left, that's -6, and I went up 2. So K prime is going to be at -6, +2. What we did after we turned it is pretended that this is quadrant 1 so that I can get the point of K prime. Now I'm going to turn it back to my original position. So this is back where K started, remember, before we even moved it. But I already have the coordinate of K prime, so I can just plot it. That's the whole point. We want to turn it physically, pretend that the top right quadrant is quadrant 1, write down the information we need to, and then turn it back and plot the points. So we turned it 1 turn, 2 turns to the left. That's where we ended up. All right, rotate KLR 270 degrees clockwise. Okay, clockwise is to the right, 270 is 3 turns. So we're going to physically turn this 3 times. So here we go. 1 turn to the right, another turn to the right, 3 turns to the right. This is physically turning our Chromebook or our paper. Now we're going to pretend that the top right quadrant is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. So we're going to plot all these points. Well, K, I move 5 to the left, so that's -5, and up 2. So K prime's at -5, +2. Here we have L, I move 3 to the left, that's -3, up 6, -3, 6. R, I don't move left or right, so that's X value is 0, but I do go up 2. So here's K prime, L prime, R prime. Now I can turn this graph back to our original position and just plot those points for K prime, L prime, R prime. And it looks the same as after we had physically turned it, what position it is in. Okay, here are the rules if you do want to memorize the rule. So a 90-degree clockwise rotation is the same thing as 270 clockwise or counterclockwise, and it means that xy becomes y negative x. This is the original image pre-image to the A prime image post-image. 180 degrees, you just make both x and y negative. 270 clockwise is the same as 90 counterclockwise, and that becomes negative y comma x. So 90 and 270, you flip x and y, and then depending on which direction you go, makes one of them negative. So let's practice doing the same rotation using the rule. So I said 270 clockwise. So the rule for 270 clockwise is xy becomes negative yx. So here's our points for KLR. It's at 2563. R is at 20. So first things first, we're going to flip all of the x and y's, and then we're going to make the original y value negative. So here we go. We flipped x and y. So 5 went into the x position, 2 went into the y position, and then the original y was 5. I made it negative. Same thing for L and for R. I can plot it. It gets in the same position. I still think it's easier to physically turn the paper, but if you would like to use the rules, you're more than welcome to. All right, reflections. They're essentially mirror images or images flipped over a line. So we're going to reflect an object over the x and y axis. And to do that, you're just going to make the opposite value. So between x and y, whichever one you're reflecting over, you make the other value negative. So here are some images of reflections, and let's go ahead and practice it. They preserve congruence, but they do not preserve orientation. So we're going to reflect point D over the x-axis. So we're reflecting over the x-axis, therefore the y value is negative. So D is currently located at 2, -3. Well, if I make -3 negative, -3 really is +3. So D prime is at 2, +3. You can also look at the distance they have between the x and y axis. So here, the original point is 3 units away from the x-axis. So the reflected point should be 3 units away from the x-axis. Here we have RSTUV, this quadrilateral, and I want to reflect it over the y-axis. So when I reflect over y, the x value becomes negative. So there's the original points. All of the x values started out negative, so they're going to end up all being positive because when you do a negative, it becomes positive. So our new image should look like this. And again, you can see the distance that we reflected over, okay? Describe the transformation that occurred in the graph. Okay, well, looking at between A and A prime, they're mirror images of each other. And if you write down the ordered pairs, it looks like the Y values all became negative. So it's going to be a reflection over the x-axis because the y values became negative. Remember, reflections is always you're making the opposite point negative. Y became negative, so it's a reflection over the x-axis. You can also see that the image is flipped over the x-axis. Dilations, we're making things bigger or smaller. The types of dilations we have are enlargements or reductions. So an enlargement, we're making it bigger, and it means that the scale factor has to be greater than 1. A reduction, you're making it smaller, and the scale factor is less than 1. Now, if the scale factor is equal to 1, no dilation has occurred because I'm not changing the shape size. Dilations, please, please, please remember, it's always multiplied. So when we get our rules for dilations, basically we're looking at what number is being multiplied by x and y, and that number is your scale factor. It has to be the same number multiplied by both of them because it is the scale factor. So we're going to take this scale factor and we're going to generate a new point. So B is located at 4, 8, and our scale factor is 3. Remember, dilations always mean to multiply. So what I'm going to do to create B prime is to multiply both of the original coordinates by 3. So I'm doing 3 times 4 because that was the x value, and then 3 times 8 because that's the y value. When I multiply 4 times 3, I get 12. 8 times 3 is 24. So B prime is located at 12, 24. Now, when you're given 2 points, you can find the scale factor. To find the scale factor, it's always going to be the new over the old. Well, prime means new, so I'm going to say C prime over C will generate our scale factor. So I'm going to do 8 over 2, new over old, and that equals 4. 8 divided by 2 is 4, so that means our scale factor is 4. And when I plug into the rule for this, the scale factor is 4. So I'm going to say xy becomes 4 times x, 4 times y. Whenever you see something that is multiplied by x and y in the rules, we're talking about a dilation. Again, the scale factor is greater than 4, or greater than 1. So what occurred is an enlargement. To be a reduction, it has to be less than 1. So now let's practice this on the coordinate plane. I'm going to decide whether it's a reduction or an enlargement, and then we're going to generate the rule and the scale factor. Well, I can see that this is P and this is P prime. So going from P to P prime, I made the shape smaller, so it's going to be a reduction. So let's get the original points for P, Q, R, and S, and then we can convert them to P prime, Q prime, R prime, S prime. So P, Q, and R are negative 2, 5, 4, 2, 4, negative 4, and S is at negative 4, negative 4. Well, it looks like P prime is at negative 1, 2.5, Q is at 2, 1, Q prime is at 2, 1, R prime is at 2, negative 2, and then S prime is at negative 2, negative 2. Okay, when you are trying to come up with the scale factor, please pick easy numbers. Do not mess around with decimals or numbers that aren't exactly on the cross section. Choose like Q. We have 4 and 2. So we put new over old. So Q prime is new. So I'm going to take my 2 and put it over the 4 from Q. Now, you need to be matching up like with like. So if I choose the x value of Q prime, I better choose the x value of Q. So the x value of Q prime was 2. The x value of Q was 4. Well, 2 over 4 simplifies to 1/2, so that means our scale factor is 1/2. And remember, the rules of dilations are always multiplying, so I'm going to say xy becomes 1/2 x, 1/2 y. All right, this was our longest video. I'm going to let you go ahead and get started on the next one.